You've been there, right? On a ferry or maybe a cruise ship, you flush the toilet, and for just a second, you wonder, where does all that go? Well, you're not the only one who's asked that question. And believe me, the answer is way more interesting than you'd think. It's this incredible piece of hidden engineering, and we're going to break it all down.
Okay, first let's get a handle on just how big of a deal this is. A single, big cruise ship, it's basically a floating city, right? And it can produce over 1 million gallons of sewage in 1 week. 1 million gallons. So the obvious question is, you can't just, dump that straight into the ocean, can you? Well, the answer is kind of complicated. Turns out the answer involves a little bit of everything. There's international law, there are armies of hungry bacteria, and there's this surprisingly complex machine hidden deep down inside the ship. It's a whole system, and it all starts with the rules. Yep, that's where we have to begin. Because before anyone even thinks about building these systems, they have to follow a very strict set of international rules. It's all about keeping our seas clean. The big one, the law that matters most here, is called Marpol Annex 4. You can just think of it as the global rulebook for ship toilets. It's been around since 2003, and it applies to pretty much any big ship out there. It lays out, in no uncertain terms, what you're allowed to do with sewage when you're out on the water, and what you're absolutely forbidden from doing.
So how do these rules work? Well, it all comes down to one really important thing: how far you are from land. Take a look at this. The closer you get to the coast, where the ecosystems are the most delicate, the tighter the rules get. If you're within 3 nautical miles, forget it. You can only discharge sewage if it's been fully treated. Go a little further out between 3 and 12 miles, and the rules ease up a bit. But it's only when you get way out, more than 12 miles from any land, that you're even allowed to think about discharging untreated sewage. It's a really smart, tiered system.
And there's another little rule in here that's super important. Even if you're far enough from shore, you can't just dump anything that isn't fully treated while you're parked. Nope. The ship has to be moving, specifically at 4 knots or more. Why? Well, it's to make sure everything gets spread out and diluted over a huge area, not just concentrated in one spot. So it's not just about where you are, but also how fast you're going.
Okay, so ships have to follow all these rules, especially near the coast. That means they need a way to get their wastewater to that fully treated level. And that's where the amazing engineering comes in. So now let's head deep down below the passenger decks and follow what happens after you flush.
All right, here it is. This is the heart of the whole operation. I know. It looks a little complicated, but the basic idea is actually pretty straightforward. We can break this whole thing down into 3 main steps. This is your standard biological sewage treatment plant you'd find on a ship. The science behind this is, honestly, kind of beautiful. It's called aerobic biological treatment. Basically, the whole point of this machine is to create the perfect home for a giant colony of helpful bacteria. Think of them as a microscopic cleanup crew. They thrive on oxygen, and their job is to literally eat the sewage and break it down into harmless stuff like water and sludge. So, step 1 is aeration. All the raw sewage, what they call black water, flows into this first big chamber. Right away, a bunch of blowers start bubbling air through it, kind of like a giant aquarium. What that does is create this oxygen-rich soup, which is basically an all-you-can-eat buffet for our little bacteria friends. They go to town, start multiplying, and begin breaking down all the pollutants. Okay, after that, the mixture moves into the next chamber, the one that's shaped like a cone. This part is just simple, clever physics. All the heavy, solid stuff that hasn't been broken down yet just sinks to the bottom because of gravity. And from the bottom of that cone, it actually gets sent back to the first tank to get chewed on some more by the bacteria. Meanwhile, the much cleaner liquid naturally rises and stays at the top. And for the final step, that cleaner water at the top spills over into the last tank. This is basically the final safety inspection. As it flows through, it passes over what are essentially giant chlorine tablets. This disinfects everything, killing off any nasty bacteria that might still be hanging around. Once it's been in there for a bit, the water is considered clean enough to be safely sent back into the ocean. But what does clean actually mean? Well, the rules are super specific about this. The water that comes out, the effluent, has to meet some really strict standards. They test for everything: the level of harmful bacteria, the amount of tiny leftover solids. They even test for something called biochemical oxygen demand, which is a fancy way of making sure the water won't mess with the ocean's oxygen levels and cause something like an algae bloom. The system has to hit these targets or it's a no-go. So this whole process sounds pretty slick, right? And it is. But operating and maintaining one of these things is not exactly a walk in the park. For the engineers and crew who have to keep these plants running, it can actually be pretty dangerous.
Yeah, a sealed sewage tank is more than just smelly. It can be a death trap. The same biological process that cleans the water also creates a whole bunch of nasty, invisible threats. We're talking flammable methane gas, toxic gases like hydrogen sulfide and ammonia, and maybe the most dangerous part, not enough oxygen to breathe. You just can't go into one of these spaces without taking major precautions.
And here's the other big problem, from an operational standpoint. Remember, that whole system is alive. It depends entirely on that colony of bacteria. So what happens if the colony dies? Maybe someone flushes a bunch of harsh chemicals down a toilet and it wipes them out. Well, the whole plant just stops working. And you can't just flip a switch to fix it. It can take up to 2 weeks to grow a new, healthy colony from scratch.
Yeah, this is serious stuff. This quote from an engineering manual says it all, really. You have to pump the tank out, flush it completely, and then vent it with fresh air before anyone can even think about going inside. It's not a simple repair job. It's a major safety operation every single time.
So that biological plant is super common, but it's not the only way to do it. There's another approach out there, an alternative that works on a totally different principle. This right here is a zero-discharge system, and the name says it all. Unlike the biological plant that's all about growing bacteria, this one is purely mechanical and chemical. It uses grinders, filters, and chemicals to treat the waste. But the key difference? Nothing goes into the sea. The treated waste is held in a big tank, and then, when the ship docks, it's all pumped ashore to a proper facility.
So, you might be asking, which system is better? Well, like with most things in engineering, there are trade-offs. The big plus for the zero-discharge system is you don't have to worry about keeping a colony of bacteria alive. You can just turn it on and off. The downside? It generally needs more cleaning, you have to keep it stocked with chemicals, and it's often a bit more maintenance-heavy. So there you have it. What starts with a simple flush takes us on this whole journey through international law, into the world of microscopic organisms, and deep into some really clever machinery. It's this entire hidden world of engineering, humming away 24/7, all to make sure we're protecting our oceans.
And the craziest part is, this whole complex system is completely invisible to pretty much everyone on board. It just works, quietly, in the background. And that really gets you thinking, doesn't it? What other amazing pieces of hidden engineering are out there, just under the surface, keeping our whole world running?